Okay, so here's homework 3, the last problem, problem 5. And this one's a bit trickier because it's got a dependent voltage source, it's got a current source with 2 of the mesh currents flowing through it, so it's probably one of the harder questions you'll find. Just like everything else, it asks KVL and KCL. KCL is needed if you have a current source. We have a current source. So the first thing to note is that we do have a current source, so we need a KCL equation in addition to our usual KVL equations. And then the other thing to note is we're actually going to be after, in the end, V out. So we better not forget that. Okay, so because that current source is there, we have to find a way to avoid the current source and still have a closed path through the circuit. So I'm going to do this one. Right, so that's a minus, that's a plus, that's a plus, that's a minus. It's going in that way, so I'm going to say that's a plus, that's a minus, and it's going in that way, so that's a plus, and that's a minus. Although we could actually do it the other way, but let's do it that way. Okay, so there's our super mesh that avoids our current source. We're avoiding the current source because we don't know the voltage drop across it, and we want to apply KVL, Kirchhoff's voltage law. Okay, so then we can say that the super KVL does, we'll be going minus V1 and then plus VR3 plus VR2 plus VR1 equals 0. And V1 is 13, so it's minus 13. VR3 is just R3, which is 9, times I2, right? And then the voltage VR2, the one I've defined, not VR, the one I've defined is going to be R2, which is 6 times I2 minus I3, and then VR1 is going to be 6 times, now which way is it going? It's I1 minus I3, right, because I defined my polarities that way. And that's how I got that equation there, right? The KCL equation, well, the mesh currents that are flowing through our current source are I1 and I2, and I1 is flowing with IS and I2 is flowing against IS, so it's I1 minus I2 equals IS, and IS is just 5 amps, right? So that's how we get this equation. And then the I3 mesh, which I'll do in a different color, going around this way, and we'll do those polarities. That's just going to say that VR1 plus the blue VR1 plus VR2 plus V2 equals 0. VR1 in this direction is 6 times I3 minus I1. VR2 in this direction is going to be 6 times I3 minus I2, and V2 is a dependent source, so we want 4 times V out, and V out is nothing more than our 6 times I3 minus I2. And that's what we get. The equation we get out of that is something like, now I'm just going to check that I got the same numbers in my MATLAB, right? It's going to be 6 and then 15 minus 12, and then it's going to be 1 minus 1, 0, 1 minus 1, and there's no I3, and then it's minus 6 minus 30 plus 36, and that's I1, I2 and I3, and that equals 13 in the first instance. Right, we bring that across to the other side of the equation. It's going to be 5 for the KCL, and there's no constant in the other one. And if I run that through MATLAB, there's my MATLAB, and if I do my RF and everything, then I get those numbers. I'm not going to use that number of significant figures because it's pointless, so I just limited it to 4 significant figures in my answer down here, and that's what I get. The final thing is to figure out V out, and V out is just going to be R2, which is 6 times I3, because I'm looking at it from the I3 direction because I want to flow into the positive side of V out, minus I2. And that is problem 5.